Hey class, in today's lesson we're going to talk about rational expressions, which is found in section 8-4, part 1 of your book. We are going to simplify and multiply rational expressions. Alright, so a rational expression is the quotient. Remember we talked about ratio as far as being in the word rational. So as a quotient, which we know means division, of two polynomials. A rational expression is in the simplest form when its numerator and denominator are polynomials that have no common factors. So let's practice. It says, what's the simplest form of the expression? All right, right now we have two polynomials that are written in standard form that need to be simplified. So if I simplify both what's in our numerator and our denominator, we would need to do AC for both. So AC for the numerator, the factors we would get are 1 and 10, and then 2 and 5. So obviously 2 and 5 make up 7, so I'd have x plus 2 and x plus 5. For the denominator, AC once again would give us the same factors, but this time 2 and 5 still work, but I'd have negative 5 and positive 2. Okay, the issue here is that the plus 2's, the x plus 2's will cancel because they are common factors, and so the final answer will be x plus 5 over x minus 5, and they are different because the signs are different. So that's our final answer. Alright, so we're going to go through simplifying the rest of these rational expressions. So the first one, I like to break it down and all the way down. Yes, there is a simpler way, and I'll explain that simpler way at the very end of breaking it all the way down. But remember, I do sometimes give you the longer way because this way is fail-proof. It'll work every time. Alright, so if we did a greatest or a factor tree, 24's factors be 2 and 12, then 2 and 6, then 2 and 3. So that numerator is 2, 2, 2, 3, 3 x's, and 2 y's. That's the numerator. And then the denominator, remember 6 is just 2 and 3, but don't forget there's a negative 1. So it's negative 1, 2, 3, 2 x's, and 3 y's. Okay, from there we'll cross out what they have in common. So there's 1, 2 in common, 1, 3, 2 x's, and 2 y's. So we will be left with in the numerator 2 times 2, which is 4, x over negative 1 and y, which would give us negative y. And that would be our final answer. Okay, now the shortcut would have been just to say 24 divided by negative 6 is negative 4. If you remember your power rules, you would subtract there. So x to the third minus x to the second is x to the first, or just x. And again, power rules here would tell you to subtract, so that'd be y to the negative first power. But you have to remember that y to the negative first means you move it to the bottom. So again, our answer would be negative 4x over y, which is the same thing. I just moved the negative around. So again, we're done. All right, so I'm going to kind of use the second half, and then I'll have to erase for the final one. Okay, for the first one, again, AC 1 and 8, 2 and 4. So that'll give you positive 4, negative 2. So x plus 4, x minus 2 over 1 and 6, 2 and 3. So they'll both be negative. So x minus 2 and x minus 3. So again, what they share in common is x minus 2. So we're left with x plus 4 over x minus 3. Okay, actually I might have enough space to not have to erase anything. So on the first one, you definitely need to rewrite. Be sure it's in standard form. So I have negative 4x plus 12 over x squared minus 9. If I factor those, I can take a negative 4 out of the numerator, and I'd be left with x minus 3, over x plus 3 and x minus 3. Okay, we can obviously see there that the x minus 3's will cancel. And so we are left with negative 4 over x plus 3. Pretty nice stuff. Okay, let's keep going. All right, so in example 2, now we're multiplying. Okay, just like kind of when you were maybe dealing with proportions, maybe. Not proportions, but just multiplying fractions in general, you can cross simplify. And so that's what we will be doing here. So we want to break down all of our numerators and denominators as far as they can go, and then we will cross simplify. So we will simplify diagonally, and then we can obviously, of course, simplify vertically. Okay. All right, so let's go ahead and work on breaking these down. This first one, you have either 1 and 6 or 2 and 3. 2 and 3 are going to work here, specifically positive 3 and negative 2. So x plus 3, x minus 2, and it's over x minus 5, okay? Times this numerator, that's difference of squares, so that's x plus 5 and x minus 5, over that AC is only 1 and 3, and that's going to be x plus 1 and x plus 3. All right, let's start by simplifying diagonally. So diagonally, I see that I have an x minus 5 and an x minus 5 in common. And I also have an x plus 3 and an x plus 3 in common. Now, as far as vertically, I don't see anything vertically that can be reduced. So our final answer for our numerator is x minus 2 and x plus 5 over x plus 1. And we are done. And no, we would not then multiply the numerator. We would just leave it as factors. Okay, try 2 again. We want to break everything down as far as you can. So the first one has a greatest common factor of 2, and we're left with x minus 4. And the denominator, that's difference of squares, so that's x plus 4 and x minus 4, times, the numerator is only 1 and 4, so that's x plus 1 and x plus 4. And then the denominator, we have 1 and 16, 2 and 8, 4 and 4. 4 and 4 are going to work. So that's going to be x plus 4 and x plus 4. All right, so diagonally, we have x plus 4 to cancel. And vertically, I see there's an x minus 4 to cancel. So we are left with, in the numerator, 2 times x plus 1 over x plus 4 times x plus 4. And that will be our final answer. All right, guys, we are done. If you have any questions, be sure to come in for tutoring. All right.